For those of you joining in on the interwebs, I just explained a lot of procedural type things to the class. You don't get that discussion. So, let's do this. Okay? We said that this week in the pre-calculus, it is thinking week. Okay? All right? So let's really just take all of that stuff and let's throw it in a bowl and let's mix it all up. Okay? So, if I were to tell you, I'm going to give you a new way to do bearings. Because why not? Why not throw a fourth thing into the mix? Okay? And that new way is written with a north or south point of reference. Okay? So in part A here, what this is saying is that I am headed south with a 35-degree angle to the east. Okay? S, 35 degrees E, means I'm headed south, and I'm angled 35 degrees to the east. So, on a graph, that would be, I'm headed south with a 35-degree angle to the east. In terms of our compass rose bearing and heading, that, remember, has north up top with 0 degrees. That has east out to the right at 90 degrees. South down, straight down at 180 degrees. And west out to the left at 270 degrees. Okay? So that angle comes off of 0. The compass rose angle comes off of 0 and goes down to there. That angle would be how many degrees? 180 minus 35 would be 145 degrees, correct? Okay? So we're talking the exact same thing here. 145 degree heading or 145 degree bearing is the same thing as south 35 degrees east. Okay? So those two mean the exact same thing. Now, let's take that and let's put that back onto the unit circle. We'll go in degrees so we don't have to worry about radians and bad conversions. What would the degree be on the unit circle? Well, now the unit circle starts at 0 degrees over here, right? And then it goes up here to 90 degrees, and then down here to 180 degrees, and then way down here to 270 degrees. So that angle would come all the way around here, and that angle would be how much? 305 degrees, right? Because I'd have to go 90 plus 90 is 180 plus 90 is 270 plus 35 would be 305 degrees. Okay? Let's take it another level. We also have out there called reference angles. Refresh my memory with reference angles. They come off the horizontal, and they're positive, correct? And they are acute, right? Yeah, they're acute. Or acute. Okay? All right? So that angle is right here. And how big is that reference angle? 55? So right there, we have given you 4 different and distinct methods to do the exact same angle. Okay? It all depends upon what you're doing with that angle. If you're on the unit circle, if you're on compass rose, if you're on reference angle, if you're on modified compass rose. Okay? Alright? Good times. What I would like you to do now is I would like you to do both B and C, all 4 of them. So fill in the rest of that chart. Alright, so north 80 degrees west. So that means I'm over here, and this angle in here is 80 degrees. That tells me then that I am at a 280 degree bearing. That tells me that on the unit circle, I am at 170 degrees. And that tells me that my reference angle is 10 degrees. Do we all agree with those 4? The reference angle one? Reference angle comes off of the horizontal, which is just that one right there. Oop. Compass rose comes off of north, goes this way, 90, 180, 270, plus 10 more, gets me 280. Or I could have done 360, because that would be back to north again, minus 80. Okay. Trig angle, might as well just go off of that one too. Trig angle is 0 to 90 plus 80 more gets me 170. Okay. Part C, north 55 degrees east would be there, with that angle being 55 degrees. So that is going to be, we'll just stay up here and we'll just do them all. So that would be a 55 degree angle there for bearing, for compass rose. That would be a unit circle angle of 35 degrees. And that would be a reference angle of 35 degrees. So that would be a 55 degree compass rose, 35 degree trig, 35 degree reference. Oops, it looks like a 6. Come on. Yep. All right. Let's do some word problems. Aw, snap. Okay. So, a plane is traveling on a heading of north 65 degrees west for 90 miles. Find how far north and how far west the plane is from the aerial quartet. Okay? Now, we said that this week was thinking week. Okay? And so you have to think when you make your picture to go along with this stuff. Okay? So, a plane is traveling north for 90 miles. So it's traveling north with a little westerly tilt to it. So my plane is going north, but it's also going west at 65 degrees. So there is my plane's path. It's traveling along that path for 90 miles. Now, how you go about drawing your triangle, that is, again, totally up to you. So I could draw this triangle like this. I could also draw this triangle like this. Oops, I missed. Okay. Either way, however I draw it, because it said I was going north, here's my airport with a 65-degree angle to the west. That angle in there is 65 degrees, okay? Which puts my plane right here. Okay? Now, I could say that, well, then this angle down here is 25 degrees. I could say that this angle here is 65 degrees, and I can say that this angle here is 25 degrees, okay? Because I'm dealing with right triangles. I need to find how far north, how far north my plane is, and how far west my plane is from the airport. So I need to find those two sides, which would also be over here and up there, depending upon which triangle I'm dealing with. Okay? So one way that I could go about that would be, I could say that the sine of 65 degrees is my west component over 90. I could have also gone with the cosine of 25 degrees is west over 90. I could also go with the cosine of 65 degrees is my north component over 90. I could have also gone with the sine of 25 degrees is my north component over 90. If I solve those, my west component is 90 times the sine of 65 degrees, and my north component is 90 times the cosine of 65 degrees. So that puts my westerly component at 81.568 miles. And it puts my northerly component, at, 38.036 miles. Okay? So my plane is 30, whoa, tap the brakes. That was my book, actually just hit that. My plane is 38.036 miles north and 81.568 miles west of the airport.
You multiplied out of 90, right?
I did.
Getting the west road.
Are you using the degree symbol on your calculator?
I think I am.
Okay. Yes? What I would like you to do now is I would like you to be a captain, my captain, and sail your ship. All right, so a ship leaves port at noon and has a bearing of south 23 degrees east. If the ship sails at 30 knots, how many nautical miles south and east will the ship have traveled by 3 p.m.? So the ship is leaving port and it is traveling south and east. Okay, so that tells me then that port is up here and this down here is my ship. Okay, we need to find how far it has traveled south and east. Okay. We know that its bearing was south 23 degrees east. So I know that that one's a 23. So I need to find here south and east. Now, if it's traveling at 30 knots, what does that mean again? What's a knot? Nautical mile per hour, so it's a speed. And how long am I traveling for? For 3 hours. So 30 knots for 3 hours gets me how many nautical miles? Gets me 90 nautical miles. Okay. So here I would go with the sine of 23 degrees is equal to my easterly component over 90, and I would go with the cosine of 23 degrees is my southerly component over 90. So east here would be equal to 90 times the sine of 23 degrees, and the southerly component would be 90 times the cosine of 23 degrees there. So that gives me an easterly component of 35.166 nautical miles. Emily, you would ask, it is NM. It just popped into my brain. NM is nautical miles. Yep. Nope, I believe it's lowercase. Yep. And southerly component of 82.845 nautical miles. Huh? Yep. Fantastic. Let's try this one now. Okay? A ship is 300 nautical miles west and 65 nautical miles south of port. What bearing should the ship sail to reach the port? We're ignoring current at this point. We'll attack those problems in a little bit. Yeah, buddy. When we throw bearing and wind and current and so this one's going to make you think a little bit. Okay? So the ship is 300 nautical miles west. So west is this way. And south of port. Right? And 65 south. So my ship, so here's port. Here's the ship. There's two of them, and this is 300, and this is 65, right? Isn't it?
Wouldn't you have to convert either the 65 miles to...
Let's just call it nautical miles. There's just a typo there. Yeah. What's up?
Why is the 300 horizontal?
Because west is horizontal. A ship is 300 nautical miles west and 65 miles south. So, yeah? Yeah? Okay? All right? All right? So let's go with, so it might change tweak it a little bit. I just noticed that too. It should be nautical miles there. We'll go. Okay? What bearing should the ship sail to get back home? Okay? So the bearing that the ship would have to sail to get back home is the bearing angle from the ship to the port, which is that angle there. Okay? All right? Now, I'm going to tweak this one just a little bit. Because what if you drew your triangle? What if you drew your triangle like this? With me? This is still my ship. This is still my port. Right? I still want the bearing angle from the ship to port. So if I find this angle, that's going to be kind of like my reference angle, because the angle that I want is actually that angle there, which corresponds to that angle up there. Okay? So it's a thinking type of problem. Okay? So if I'm down here on my original one, that would be theta here is equal to the inverse tangent of 300 over 65, which would be, that would give me, actually I can go right to that one. That would give me an angle here, theta if you will. Theta here would be 77.775 degrees, which would be the bearing that I, as the ship's captain, would have to get back to port. Okay? If I wanted to write that as, I would be heading north, 77.78 degrees east. Because I want to go that way. Because I'm going to the left, or to the right. Right is east. It's either one. Yep. Just putting it in the new one of today. Okay? If I'm over here, then over here, theta prime is going to be the, oops, I should have put some measurements in here. This would have been 300. This would have been 65. So that would have been the inverse tangent of 65 over 300. Okay? And that would have given me 12.225 degrees as that angle there. And then to find the bearing, I would have to go 90 minus theta prime, which then that would give me 77.775. Yes, ma'am?
Instead of saying 77.775 north and east,
Yep.
could you just say 257.775?
No, because that's if I'm going from port to the ship. With me? Okay. You found that 257 one is from here. From if I'm at the port and I'm going back to the ship. Okay? I don't want to do that. I want to go from the ship. It's asking what bearing should the ship sail. Now, the port's not coming to me. I'm going to the port. Okay?